Okay, so hi, my name is Pim. Today I'm going to present about my high school math 2 big project for quarter 3. So first, in this project, I will be doing many tasks mainly about geometry, which is there will be kind of new kind of problems for me to solve. For example, the finding the width of the river. Yeah, the first part is for my title is the amazing geometry. Okay, so first part is the introduction, which in quarter 3 I've learned mainly about geometry. So this is the time when I will show my skills that I really understood what I learned. So I learned many things about new topics, about each terms like isosceles triangle, median of triangles, and angles like complementary, supplementary, and stuff. And I also learned how to use the GeoGebra app, which really helps me because in each problems when I see the picture of it, it really helps me understand quicker and easier. And the objective of this project is to be able to solve all of the tasks given, and compare and identify the two figures, prove how is it similar or congruent to each other, and measure the width of the river using trigonometry, and find the height of the two cans, and see which uses, and find the surface area of it, right? The limitations of this project is that it's about the things out of control because it's possible for me to go and measure the exact size of the tree or the river, so I need to use kind of the skills I've learned to measure it. So first I will go through the pages to see each task I need to accomplish, and then try to figure out the ways how to solve the problems. So there are many problems about geometry to define each term, solve the problems, and compare and identify about the dilation or rotation of the triangles. So the first task for the result part is that define these terms and create a figure for each. So start off with isosceles triangle. It's triangle that has two sides of equal length. So line AB and line AC are congruent to each other. And the next one is median of the triangle, which basically is the line segments that join a vertex to the midpoint of the opposing side. So it's this thing. And the centroid of the angle, which is in the middle part over here. And the midpoint is the exact middle point between the segments here. A perpendicular bisector of a segment is the line that cuts through the line segment. And the angle bisector, this line. Complementary angles, the two angles that add up and get 90 degrees. Supplementary is two angles which add up and get 180 degrees. Corresponding angles, so the two lines that cross by another line here, the transversal. Alternate interior angles, which is the orange one, and alternate exterior angles are the purple one out here. Vertical angles are the angles that stays opposite of each other. Transversal, this line. Parallel lines are the two lines that do not intersect or touch each other at any point here. So these two lines are parallel. The vertex, this part, and the point is this thing, the point. And the line is like a collection of points that go along and does not have the end point, but a segment does have an end point. And the ray, it has one single end point and it extends to infinitely in one direction. So this is the end point and it goes in one direction. Okay, so the next task is to construct a quadrilateral and prove it is a parallelogram. So this is a quadrilateral. So I used a GeoGebra to like kind of make this and then label of like the coordinates of each point. So I first, the slopes are the same because they're parallel to each other, and to prove that, I find the slope of point B to C and A to D, which is m equals to y2 minus y1 divided by x2 minus x1, and both of it gets equals to 0, which is the same. And the corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent, and opposite lines are parallel to each other, and diagonals bisect. Proceed to the next one, which is construct a parallelogram and prove that it is a rectangle. So it's kind of the same thing as the previous task. So first I label the coordinates and then make a triangle by the GeoGebra. Find the slope, and then two slopes has the equal number, which is 0, and they have the same slope and like corresponding angles are congruent, and opposite lines are parallel, and the thing that is different from the previous one, which is the consecutive sides here, they're perpendicular to each other and diagonals bisect. The fourth task is draw a triangle and dilate it by the scale factor to 0.75 and prove that the two triangles are similar. So first, the two triangles are similar because the angles in between both the sides are congruent. The corresponding sides are in the proportion, and the corresponding angles are congruent, and parallel lines here are parallel, and the midpoints remain in the middle of their line segment, and angle measures stay the same, so they have the same angle still, even though they are in different size. The next task is about rotation. So I made one triangle over here and then I rotate it by 45 degrees Celsius. 45 degree counterclockwise. So this thing is the original one, and then I rotate 45 degrees, so it became this thing. And these two triangles are congruent because the two sides and the included angle of one triangle are equal. So these two angles are still the same, even though they stay in different positions. And they are congruent to the corresponding sides and angle of another triangle. So we can prove it by like use the side angle side, or angle side angle postulate. So it's up to the figure that you draw. The next task is about find the width of the following river using trigonometry. So this is the river the picture of my river, the one that I want to measure. So first I moved about 5 meters to the left. I stand right, like opposite of the tree, and then I move like about 5 meters to the left. So B equals 5, and then I measure the angle of the triangle, which I get here 47 degrees. And then I want to find out that what's the width of this river, which is A. So I already know what is the B, which is 5. So I use the tan formula to solve, which tan times 47 equals opposite divided by adjacent, but I want to know what is the opposite, which is over here. So I rearrange the formula, which is opposite equals to 5 times tan 47. So after I calculated, the width of the river is 55.3 meters. Yeah, so this is my answer. The next one is about basically about cutting the tree, but when we cut the tree falls down on the ground, but not to the house. So this is what I have. So this tree is the one I will cut, and the distance from the tree to the house is about 4.5 meters. And the angle of it is 57 degrees. So I use the same, which is tan formula, and then I find the opposite, which is the height of the tree. So I use opposite equals to 4.5 times 10 to 57. So the height of the tree is about 5.61 meters. So I know that when I cut the trees, I have to it is about 5 meters to 6 meters tall. So I have to have enough space so that the tree doesn't hit to the house. And the next task is task 8. So it's about fun size can. So basically, we want to figure out the height of the cans and the surface area, and figure out that which can uses the smallest amount of aluminum. So first I did kind of put different 1 to 5, 1 to 4. So I 1 to 4 instead of the radius. So this is what I got. So the first one, this is the answer. This is the answer until I did to 4, and then I come and see which number, which answer has the smallest amount of number, which is end up with the radius 3. So which means the answer is that radius of 3 uses the smallest amount of aluminum, which for the cans I used a radius of 3 and 4, which ends up getting the height of 7.07 and 3.98, and the surface area is at 189.7 and 200.4. So this is what I did. And for the discussion and conclusion, so in each task I solve it by using different standards I've learned so far. So about defining each terms, construct the shapes, and find the width, and then compare the triangles, which in this project I do many tasks to prove that I really know what I'm learning about. And there are so many new topics that I've never learned before, and for example, and it's also important for me to know because we can use it in real life. For example, cutting the tree, we can know the height of the tree without climbing and like really measuring it. And for the common core standards I've learned in this quarter is about the proving the theorems of about lines and angles that I used, about the complementary, supplementary, corresponding angles like vertical angles. And I know that I learned it because like I know I prove how to like prove whether the angles are complementary, supplementary, like I can identify it. And we also can use it in real life, like for example when we drive car we can like kind of measure the angle that we will turn the steering wheel. And I also learned about the measure of a triangle. So like using the GeoGebra app to find a segment that joins the midpoint of a triangle, which is parallel. And TCO 11 about proof about parallelograms. So like to prove that the opposite sides of parallelograms are congruent, like finding the does the diagonals bisect to each other, and like we can use it in real life. For example, we want someone to rent a booth to sell something, we can use this skill to like find the parallelogram to find the equal size of booth for everyone. The next standard is about similarity, right angles, and trigonometry. So the SRT 1, it's basically about like moving the figure around like by like dilation or like to make it bigger or smaller without changing the distance, like just the size of it. And I know I learned it because I can dilate the shapes, but I also can prove that the two shapes are still similar or congruent to each other even though the sizes are different. And can be helpful for the architect to like draw and like draw to build a house and like draw the small one, dilate it first, and then to make it into the big one for the real house. I also learned about like using the terms of similarities to decide whether the triangles are similar or not, like compare and decide, like not by like figuring out is the triangles have equal corresponding pairs of angles, and the sides, is it proportional to each other. The next one is about proving that the two triangles are similar even though they have like different transformation. So for example, prove that the triangles are similar by like the correct postulation. So for example, like side angle or side angle side. So we can use it. For example, I want to move the table in my room to like to be reflected from the same position. I can use this skill to help. And the next one is like the line parallel to like the theorems about a line parallel to one side of a triangle that divides the other two proportionally. So like identify and figure out whether the triangles are similar to each other or not using the Pythagorean theorem to prove it, like telling that the lines are parallel to each other or one side of the triangle divides other like equal or proportionally. And the next one is about using congruence to prove that the triangles are similar. So I can prove like relationships in geometric figures, like for example, to use the skill to solve the problem of like a given square and then prove that the lines are congruent to each other and why. And the next one is about, so I combine these three standards, which is mainly about the similarity of side ratios in right triangles, the properties of the angle in the angles in a triangle, and like also use the trigonometric ratio for like acute angles. So like explain and use sine cos tan of the complementary angles. For example, if we want to find the height of a mountain, we can like use the correct formula for it. And we can use it in real life. For example, like flying a kite, we can like use this standard to measure how high off the ground the kite can like how high would be the highest measurement of this kite. The next standard is about finding the center and radius of a circle. So like given by the equation. So we can use it by, for example, we want to fill in one circle, like what is the area of it. So how many, so if we want to put a shoe into a triangle floor, we can like measure how big is the area. And the next one I learned about the equation of a parabola given to find like the directrix using this formula. So we can find the equation of a parabola and like use the coordinates to justify the answer. And we can, I learned it because I'm able to find the directrix of the parabola given and use it to find the equation of the parabola using the coordinates to justify the answer. For example, drawing a kind of like a rectangle, and like to figure out the question, we can find the slope and find that it is the slope like equal to each other. And the next one is about proving simple geometric theorems algebraically. So for example, I have to prove the figure by 4 given points in the coordinates. I can like prove or disprove that the figure is like is it like the point lies on like the center of the circle. And the next one is about finding the point of the direct line segment between two given points. So for example, a line segment within points A and B can be like partitioned by another point given a ratio. So we can like solve problems to find the midpoint of the given line segment or like coordinates. And we can also like use it for the people who do like computer software to design a video game. And the next standard is about geometric measurement and dimension. So I learned about using the formulas of like the shapes like cylinders, pyramids, cones, and spheres to solve the problem. So these are the formula for cube here, for rectangular, prism, cylinder, pyramid, cone, and sphere. And I know that I learned it because I'm able to like identify which formula I should use to solve each problems correctly. So for example, using the formula of sphere to solve the problem about a snowball. And the next one, I combine two standards, which is about giving an informal argument for the formulas of like circumference of a circle, area of the circle, volume of like cylinder, pyramid, and cone. So for example, if I have like a perfectly shaped snowball with a diameter of 8 centimeters and half of it falls off, so like the half of it falls off is like the key point, which I know that I have to divide the answer before I answer the final one. So I'm able to like use the correct formula here to like get the correct answer. And the last three standards I've learned is about geometric shapes, like how to measure the size, volume of like the shapes, and like the properties to describe the objects, and use it to like solve the problems. And I can also find the volume of the figures like a mountain, which I can use a triangle, kind of a triangle formula to like find what is the volume of like, mountain shape, kind of. And I can also apply it in real life. For example, use the skill to like figure out the volume of like a ice cream cone. Yeah. So that's it for Hoi 3. And these are some references which I use. Mainly is the geometry app which I like draw the figures from. So these are all the results and like parts of my math big project quarter 3. So thank you.